what we need to find, if we want to find this guy, we need to find this first. We need the empirical formula first. And we just reviewed empirical formulas, yes? Right? And what's nice is actually they skipped a step for us. I skipped a step for you. Right? We're starting right in grams. So what was our step from grams? Grams to moles, divide by small, multiply till whole. Alright? So start by finding your empirical formula for this N and this O. I'm going to actually let you guys practice it.
No.
Please do. Yes, guys. So we get it? And 205?
That's the empirical.
Yep, for the empirical. I have confirmation on that? Somebody else got that?
Yeah.
Awesome. Alright, so this is the reduced one, the simplified one. But the actual molecule, whatever the actual molecule is, has a molar mass of 108 grams per mole. So the bigger one has this molar mass. Well, could we compare this larger molar mass to our smaller molar mass? So it looks like it's going to be, let's go ahead and find the molar mass for this molecule. 2 times 14.01 plus 5 times 16. What do you get? 108.02 grams per mole. Oh, nice. So how many times bigger is the actual molecule than our empirical?
It's not.
One, what do?
Keep it.
You keep it. This is both your molecular formula and your empirical formula, and 205. Now, if this number was bigger, all you would have to do is take this divided by the smaller molar mass. Now, I'll tell you how many times bigger it is, and then just run that number back through your empirical formula. For example, if I told you it wasn't 108 grams per mole, if I told you it was 216 grams per mole, that means it's 216 divided by 108 gives you 2. You'd run 2 through this, and your molecular formula would be N4O10. Is that right? Cricket.
Yes.
All right. Hydrocarbons, is that next? Hydrocarbons. Remember the first 4 were different. What was our saying for the first 4? Meat, eat, peanut butter. And for all of our hydrocarbons are going to end in what? Ane. Meat, eat, peanut butter. Meth, eth, prop, bute. All of our endings are in ane. Oh, that's not right. There we go. So, write the formula for the following compounds. This side, take the first 2. That's right. This side, take the bottom 2. Have to have some interaction, because otherwise you just keep talking like a honey. You guys never say that, right?
No.
At least in my face.
So I turn, smile on Roman's face, like, I think it all the time, but I'm never going to tell you that. What's the prefix tell us? Number of carbon. So C deck is 10. Somebody on this side get the hydrogens? So I do, what do you do? Carbon number times 2 plus 2. I like it. So heptane would be
6, 7, H16.
I like it. Other side of the room, pull your weight. Propane. C3. H8. I like it. Methane.
CH3.
CH. So we've got 1 times 2 is 2.
Oh,
Plus 2
plus
is 4. Good. But wait! There's more. Nice. Go the other way. Name them. We'll flip. This side take the first 2. This side take the bottom 2.
This is why I'm here.
C2, me eat. Ethane. C5 is pentane. C8, octane. C4, butane.
What is 6 and 7?
6 is hexane. 7 is heptane. Not sep. That's what I see this a lot. I'm not sure why. We get septane. Heptane. Sep like 7, like
7 in French.
septane. Oh, that's probably it. Good to know. Alright, what next?
Covalent bonds. Wait.
Covalent? Oh, no. Oh, it's okay. You said covalent. Right, the formulas for the following compounds. Covalent are the fun ones. They tell you exactly how many are in there.
Except we haven't done those all year.
Yeah,
Except in the beginning.
What?
Except in the beginning.
that'd be too easy.
We'd use ionic a lot. Got away from electric a little bit. We got the first one?
SC, F6.
SE, S6. Alright. Second one. HI? Okay. HI for the second one. Third one?
CO2.
Cl2, F2. And last one?
B2SO.
B2, S,
O.
Si. Silicide is silicone. Silicon? So it'd be B2, Si. Notice if the first element does not have a prefix that's a 1, anything above that, then we have a prefix on the first one. We always have a prefix on the second name there. Cool. What's another way you can name this? Bonus learning. I love it. Strong acid hydro. Iodic acid? Yeah. 2 names. Like it. Oh, go the other way. By the way. There's more. Try going the other way. Got the first one. Yeah. Trichlor, and we don't change the ending on the first one, so it's kind of weird. So we'd actually say trichlorine monoxide.
Yes.
Nice, I like it. Who's got the second one? No? Nitrogen dioxide, I like it. Third one?
Triphosphorus.
Triphosphorus hexoxide or hexoxide. Good, I like it. Last one here. It's kind of fun to say. Tetratellurium octiodide. It's just fun. I think. Tetratellurium octiodide. There's lots of strong consonants going on there. Tetratellurium octiodide. Good. Now what?
Acid.
Ion.
Oh, acids edged out ionic just by that much. Acids. Write the formula for the following compounds. Acetic acid. Oh, that should be super easy after our last unit. Right?
Yeah.
Acetic. No hydro means it's a polyatomic acid. So what's the polyatomic? Ic goes to 8. Acetate is C2H3O2 with a 1 minus charge, making an acid.
Put one each of the front.
H on the front.
Make it.
Balama. Gadoosh. Hydrobromic. HBr. Sulfuric.
H2SO.
Yeah, H2SO4. Hydroiodic. Oh man, I'm stealing from other slides. Let's do that one. Right. Mono or polyprotic?
Mono.
Mono or poly?
Mono.
Mono or poly?
Poly.
Diprotic, good. Polyprotic. Mono or poly?
Mono.
Strong and weak?
Weak.
Acetic acid we drink.
Weak.
Weak. Hydrobromic?
Strong.
Strong. Sulfuric? Strong. Hydroiodic? Sorry. Hydroiodic would be strong as well. Strong as well. There's only one. We call these binary acids. Just 2 different particles in there. There's only one binary acid that is weak, and that's our hydrofluoric. Good. Well, that's obnoxious. All right, name them. Do we just want to do this class?
Yeah.
What are you call this guy? Phosphoric acid. This guy. Nitric. Hydrofluoric acid. Notice, guys, when it's one of these polyatomics, when these ternary acids, we don't use hydro. When it's our binary acids, we do use hydro. This is when we use our hydro. So hydrofluoric acid, hydrobromic acid. Good. Nice. All right. Now ionic. Provide the charges for the following ions. Sodium would be 1 plus. Calcium 2 plus. How you doing that?
I don't know.
Oh, so if we go to the periodic table. If I have sodium, how many valence electrons does sodium have? Oh, we're back to electrons. 1 valence electron, is it easier to gain 7 to fill the octet or lose 1 and drop it down? Lose one. If you lose one negative particle, you become positive. If you lose a negative, you become stable, but your charge becomes positive 1. Sodium's a +1. Calcium, 2 plus. Oxygen,
2 minus.
2 minus. Helium,
Stable.
tricky. So the charge would be 0. Noble gas. Nitrogen,
3 minus.
3 minus. Bromine,
1 minus.
1 minus. Needs 1 more electron to be stable. Hydrogen,
1 plus.
1 plus. Or 1 minus. The hydride ion. Usually we think of it as a 1 plus. But every now and then, it'll be a 1 minus, which is just kind of weird. But it happens. Good. Alright. Oh, formulas and the charges for our polyatomic ions. Sulfate. SO4, 2 minus. Phosphate. PO.
CO4 3 minus.
PO4, 3 minus. Carbonate.
CO3 2 minus.
CO3, 2 minus. Nitrate.
NO3 1 minus.
NO3, 1 minus. Acetate.
C2H3 O2 1 minus.
C2H3O2, 1 minus. I like it. Hydroxide. OH, 1 minus. And ammonium. NH4, 1 plus. Remember I said way back when we first learned these, I was like, once we learn these, the rest of this year and this year kind of become easy. You used them a lot. Like a lot. Streaking the board in the video. That's not enough. Sorry. There. Alright. Cool. Alright. Alright, put them together then. We know our ions, we know our charges, let's put some together. Write the formulas for the following ionic compounds. Sodium we said was Na, charge of 1 plus. Nitrate is NO3, 1 minus. Happy camper? Plus 1, 1 minus, they cancel out. Our final formula would be Na, NO3. Na, NO3. You guys try the next one.
Well, iron is Fe. And it says it's 2, so it's a charge of 2. And then phosphate is PO4. And it has a charge of 3, so you have 3 in the iron and 2 in
Skadoosh. Sorry, I need to go and watch Kung Fu Panda now. Skadoosh. Sorry. Good, I like it. Ammonium sulfide. Ammonium is
NH4.
NH4, 1 plus. Sulfide is S,
2 minus.
2 minus. Happy camper? Nope. Crisscrossing down. Gonna have NH4, 2, F. What? What? Why? You don't want 42 hydrogens in there? Alright. Yeah, that'd be bad. That'd be a lot of hydrogen. That'd be a lot of hydrogen. Good. NH4, parentheses 2, NRS. Good. Copper and sulfate. Brooke, you want to take this one?
CO2.
You got it. Copper is?
1.
So it's got a charge of 1. What's the symbol for copper?
Cu.
Yeah, original Latin, cuprous. Bonus rating, sorry. Sulfate is?
2.
What is sulfate first?
SO4.
SO4 with a 2 minus charge. So then you would crisscross them down. Cu 2 SO4. So you got this. You got this. You made me think it's early. Notice the difference here, guys. I'd no oxygen. 8 are oxygen. And that's why those 2 are on there like that. All right. Oh, and Jesus, messy. Go the other way. Ooh. Each row, take one. So you guys get the first one. You guys get the second one. You guys get the third one, and you guys get the last one. You're in here. Yep. Yep, they're already stable. We've already balanced them. We're just trying to come up with a name. Name them.
Magnesium sulfide.
Magnesium sulfide? Looks good to me. Any others? Berry bromide? I like it. Good. Copper 2. Oxide. Aluminum carbonate.
Wait, so the 8 is only when an oxygen attached to
When it's one of our special polyatomics.
the
Yep. Good. That makes sense. Oh, less messy. I like this. Like, where did I put the image? Do we match? Ooh, I should have capitalized that. That's not good. Ah! There's all of our 4 naming systems. Notice that your ionic and your acids are kind of similar in that you do have to watch your charges for both of those. Here you've got prefixes to tell you exactly how many are in there. Here you've got prefixes, how many are in there. What else? Ooh, that's not all for Unit 5. So we're on to Unit 6.
Wait, when do we do Unit 1 and stuff?
Unit 1, we're not doing official review sessions. However, if you want to spend some time, we've got some students coming in during Liberty Hour today. Liberty Hour B. That's why I wanted to have these in the morning so that we can review the ones just for this semester. And then if you have other questions, that frees me up to have to take individual questions during Liberty Hour.
So we're just going in order from here on
5, 6, and then 7, which is stoichiometry, is going to be on Friday.
out? Okay.
And then Units 8 and 9 I'm going to kind of put together, which is gas stoichiometry and KMT. And then the last little section is going to be our acids and bases.
Okay. Is the final gonna have nuclear stuff on it?
It may have just 1 or 2 questions. It won't be very much, but there'll be a couple probably. Just a couple.
We're gonna dress in the suit today.
I was not planning that.
I'm just throwing it out there. That's pretty cool.
No, nobody sent me a picture, so.
Yeah, someone posted it on Twitter.
Okay. With a Breaking Bad comment, I'm sure.
That's what my mom did
Breaking Bad.
too. Yeah. Came out dressed like Walter White. Getting off topic, sorry.
What else? State symbols, you bet. Fill in the state symbols. Give me some letters. Solution?
AQ.
AQ, aqueous, good. Precipitate. S for solid. There's no P for precipitate. Precipitate is formation of a solid. Good. Gaseous?
G.
G. Soluble. What does that mean if you're soluble? You dissolve in water, so you would be aqueous. Good. AQ. Solid?
S.
Liquid?
L.
Water?
L.
L. Powdered metal.
S.
Solid as well. Good. Keep good.
You should have these as like every one question. 1 point for each.
1, 2, 3, 4, 5, 6, 7, 8. There's 8 points.
Do that, please. They call
Alright, now what?
Briefly, are all acids and bases aqueous?
Yes, for us right now. Yep. And the salts they form for us right now are all aqueous as well. We'll find that that's not always the case, but for us right now it is. Yeah. Bouncing! Woohoo! It's been a while.
Oh,
This room.
It's been a while. Alright. Ooh, I kind of picked some maybe a little more involved ones for this. Alright. Try the first one here. I would guess, with the practice that we've had, you guys have gotten way better at the balancing. I know it's kind of frustrating for some of us at the beginning because it's like, there's no, give me the steps, give me the rules, tell me how to do it. Oh, it's a back and a forth.
yeah, you have to sit there for like 10
To
minutes.
an extent, there's a little bit of trial and error there, trying to get it to go right. Well, we've got, looks like, just pick an element, 1 nitrogen, 2 nitrogen, so we'll
One,
need
two,
2 on this guy. We've got 2 hydrogen, 1, 2 hydrogen, good there. We've got how many oxygen then? We got 4, right? 2 times 2 is 4, plus 1 is
5.
5. We've got
5. Hey!
not
That
so
was
bad.
not bad.
Alright, okay. It's all good. All good. Alright, give me an element. What are we going to start with here? Manganese. We got 1 and 1. Always look for your arrow, guys. That's your pivot point. Especially on this one because it kind of ran out of space over here. Apologize for that. How many oxygen? 2, 4. We've got
6, 7.
Let's come back to that oxygen. We're going to be able to pick up the oxygen using this lone oxygen here. Okay? Another good tip when you're balancing these reactions, always leave that lone element by itself until the end, because if you change its coefficient, you don't change anything else. If we put like a 3 here, that would change the oxygen and the manganese. So it's kind of one of those tips or tricks you can use. Well, bromine we've got 2, and we've got 4, so we'll need 2. All right. We're still not right with our oxygen, are we? Which oxygen's getting us goofy?
Yeah, well, there's
Because we got
we have
4, so we've got 6, 7. Is there any way we can get an even into an odd?
Yeah, we can make bromine.
Yeah, let's make this guy even. Because if we can get this guy even, then maybe we'll be able to get the other one. So let's go ahead and multiply this by 2. Oh, but that changes the bromines. Now we've got 4, 5, 6. So we'll need 3 here. We've got 2, 4. We've got 6, 7, 8.
So put 4
We've got 2 here.
or 3.
So we need 6 more here. Let's put by 3. Let's try the next one. Ooh, what type of reaction is this next one? Yes. This problem's on fire. No? Not the
No.
same? Funators.
Just too early.
All relative. It could always be.
Oh, Jesus.
Did you just get that hydrogen part?
Yeah, I just
Yeah,
got the hydrogen part.
hydrogen part.
I was like, oh, this is gonna work out perfectly. No, never mind.
Womp womp. Another trick, guys. Got 22 hydrogen. So you want to multiply this by what?
11.
11, but that makes an odd number of oxygen.
Yeah.
Mm-mm. So what I would do, if that was the case, I would just go ahead and double this. Whatever coefficient we got here, had 11. Go ahead and double it. Make it 22. That does what to your hydrogen over here? 2 makes how many carbons?
20.
So we'll need 20 here. Ooh. All right, oxygens. We've got 40 plus 22 is 62. 2 times what gets you to 62?
So 2, 3, 1, 20, 22.
Big ol' hydrocarbons. Need lots of oxygens to burn it up. Dude, you guys take the last one? Sorry, I meant to let you guys take that. This bottom one should be a little nicer. Megan, you already got it? What'd you get?
I got 1, 2, 2, 1.
1, 2, 2, 1?
Yeah. Well,
Ooh, I didn't fill in the lines, did I?
no, that's
Hey, put 3 for it.
Did we?
For the
Did you say when we had 3?
Oh.
it has to be 3.
It has to be.
4.
Oh, you just
Yeah, I had it wrong. Sorry. That's one for Mr. Jorgensen. Take it out of my pay. Yeah, good catch, guys. Thank you. Nice. American. Alright, what else you got? You got, looks like 3 left. Types? Sure. There were 5 types of chemical reactions. What were those 5 types? Single displacement, double displacement, combustion, somebody said what? Decomposition, synthesis. Those were our 5 types. Name them. What type is this?
Combustion,
How do you know?
oxygen, and the.
You're burning something in the presence of air with hydrocarbons. Always gives you CO2 and water. What about this guy? Double D. 2 compounds. Switcheroo. 2 new compounds. Like it. This one? Double D. Double displacement. The wife swap show, right?
Yeah.
Yep. This guy? Synthesis. Getting married. This guy? Decomposition. Getting divorced. This guy?
Wait,
Combustion.
here's combustion.
Combustion. First one. What wasn't up there? Single displacement. We didn't have one.
Attention teachers, Daisy Myrick, can you please call extension 5467? Daisy Myrick, please call 5467.
That would not be. Alright. Now. Predicting? Predict the products. Ah. We've got one element reacting with one compound. What type of reaction is this? So here's our single displacement. What do we get in a single displacement reaction? We get a new compound and a single new element, correct? So the chlorine is going to replace somebody in here. Let's look at our charges. What charge does chlorine form?
1 minus.
1 minus. Potassium is 1 plus. Bromine is
1 minus.
1 minus. Who's the chlorine going to want to get with? Potassium or bromine? Potassium. So we're going to actually come and we're going to kick out the bromine. Make potassium chloride. 1 plus, 1 minus. That guy okay? And bromine gets a boot. What do you know about bromine? Diatomic. Good.
It's CO2.
Hmm?
CO2.
It is. Yeah, because chlorine is also diatomic. But when we write a stable compound, we're only going to make enough so that we have a plus 1 and a minus 1. If we had 2 of them here, it won't be stable. So we would write it like this, and then we would get it to come out right with the balance. 2 chlorine, 1 chlorine, so we would need
1, 2.
2 here, makes 2 potassium, so we would need 2 there. I think good. What type of reaction is the second one here? Double displacement, what happens there?
Trade.
We do a trade. Now the silver and the sodium are going to flippy floppy. Would they ever go together? +1, +1, do positives? Nope. Double check your charges, it's all those charges. So we're going to have, instead of NaCl, we're going to have NaNO3. Get our partners together first. And then AgCl. Check your charges. Sodium is 1 plus nitrate. Minus silver. Plus chlorine. And minus. Everybody okay?
Yeah.
What's our balance? 1, 1, 1, 1. What are your products for the next one? CO2 and H2O. Always. Always. CO2 and H2O. And what's the only thing this last one can do? Decompose, separate. So you'll have mercury. Is that diatomic? Hg? Oh, so just Hg. But oxygen
Is
is diatomic, so you have O2. I did not balance those. So you need to go back and balance them after you got those products in there. Cool. Solutions of calcium chloride and potassium carbonate react to produce calcium carbonate, precipitate, and aqueous potassium chloride. Could we write a balanced chemical equation including state symbols? What do you want to do first?
Start with the reactants.
Start with the reactants? When I come across a problem like this, I always just go ahead and underline my chemicals. Calcium carbonate and calcium chloride. Alright, calcium chloride is
CaCl.
CaCl, calcium chloride. Check your charges. Calcium is 2 plus, chlorine is,
1,
so we need
2,
2 of them. Solution is
aqueous.
aqueous. Adding to that, potassium carbonate. Potassium is okay with charge of 1 plus. Carbonate,
CO2, CO3, 2 minus.
CO3 with a 2 minus charge.
So 2 potassium.
Potassiums. This is solutions of, so this is also solutions, going to be
Aqueous.
aqueous. Alright. What type of reaction is this? A little displacement. So I could potentially at this point ask you to figure out the products, right?
Yeah.
Which would be fine. We could do that. But took a step further, I told you. We got calcium carbonate. You just told me this is a 2 plus, a 2 minus, so that's going to be stable. Potassium chloride, KCl, 1 plus, 1 minus, going to be stable. Calcium carbonate precipitate, so this is
A solid.
solid. Precipitates are solid. Aqueous, potassium chloride.
I think it's aqueous.
Thank you. Salt's going to dissolve in water. What's left? Balance, what do we need?
2. Yeah.
That's it? Nice. So the question for you guys, would it be helpful if I post this on the Blackboard site?
Yes.
Yes.
Oh,
Okay.
you might want to fix that one.
I will make sure to fix that.
Is the PowerPoint on Blackboard?
I'm going to post the PowerPoint and the videos that I took of us just kind of walking through these. Can I ask this question? What would make it better?